Thank you, Madam Chairman. Dr. Moore, let's expand for a moment on your comments in your opening testimony and just now about the Mesonet system. And for our friends in the room who've never been exposed to it, this is a network of weather data gathering sites all over the great state of Oklahoma. There's what, probably 30, 40, 50 information points from subsurface soil temperature to wind to a variety of things. And it is fully accessible to everyone, correct?
Yes, and it's well over 100.
Well over 100 sites. So can you discuss for a moment, teeing off of what you've said about the challenges in other parts of the country, about how the model could serve, it could be a model for the rest of the country in enhancing our forecasting?
One of the areas that the Mesonet, first of all, let me back up from that and say, when we look at satellites, particularly those satellites that are in polar orbit from pole to pole, that's really collecting global information that is extremely important for numerical weather prediction 3, 4, 5 days out. But when you're into the end game of a very intense situation, that's when the geostationary satellites and the Mesonet really begin to play their role, because they're giving you timely in situ information in the battle zone, in where the weather event is happening. And that's proven extremely valuable in Oklahoma. I should also mention there are many other benefits. We have something called OK Fire, which basically allows a farmer to come onto the Mesonet and query with their zip code, can I burn the field today? Is it okay? And so the soil temperature information, the wind information is allowing the people to make better decisions. Now, these are weather related, but is an additional benefit to the predictive capability, particularly in that end game situation.
And that information is available to everyone.
Yes, it's on the web, and I mean, this is something that when I moved to Oklahoma, I really didn't know about this, and all of a sudden I thought, well, this is really important. It allows me to have in situ information all over the state. And this is something that we really need at the national scale. And as I also mentioned, we need to take that information into the lower part of the boundary, into the lower part of the boundary layer of the atmosphere to get that in situ information that is really needed for weather prediction as you get into an end game situation.
To continue, Dr. Moore, I'm, of course, very proud to have introduced the Weather Act of 2017, which was signed into law a little more than a couple of years ago to provide weather research and forecasting improvements, weather satellite data innovation, to try and drive things forward in a coordinated fashion. In your experience, have the goals of the Weather Act been met? Tell us about the implementation.
No, I don't think they have. I think that this is going to be challenging. We have operated in a certain way in terms of improving our models for a long time, and we are going to need to think afresh about how we do this. As I mentioned, I believe we have the greatest scientific talent in the world, in the United States, in the area of meteorology. But it needs to be marshaled and applied to this national and global challenge. There are really many opportunities out there to allow this to happen, and I think the EPIC initiative is really at the fundamental level. But there are other elements that are right teed up for this. For instance, cloud computing. This may be a whole new way in which teams can form around critical areas and involve the cloud in a collaboration in terms of improving the models, because we've got to make that improvement.
Yeah. Speaking of that, and I address this to the whole panel, and we've all referenced EPIC several times, would anyone care to expand on how EPIC will help improve that, that weather forecast, that skill when it comes to extreme weather?
I'll let my colleagues speak.
Absolutely.
Yeah, I think one of the values of EPIC is the two-way interaction between the research and the operations. So it's critical for scientists to understand the forecast needs to enable the science to be relevant. So this continual iteration, this two-way flow can really accelerate and catalyze the research to operations.
And I would just add to that, just like any good decision-making and problem-solving session, when you have more voices and ideas at the table, you have more diversity of thought to challenges. And so I think by bringing the academic community and the best ideas from academia and other partners into the process of the American modeling system, you're just bringing more good ideas to the table.
Well put, Dr. Shepard. Yield back the balance, or my time's expired, Madam Chair.